Hello students, welcome to this video tutorial, more probability examples. So please make sure that you've got your calculator out or you've got your calculator app open on your computer. All right, example 1. There is a six-sided number cube. So whenever you hear about a number cube, it just means a die, okay? Like dice, dice is plural of a die. Six-sided number cube. So we have the numbers from 1 to 6. And a coin. If you roll the cube and flip the coin, so this is a classic probability experiment, list all of the possible outcomes. So when you list outcomes of two different events, make sure you do it in an organized fashion. Don't just do it random, because it's very hard to keep track of the events or the outcomes that you've listed. So if we start with the number cube, and we should because that's the first thing that's listed, if we roll it, we can get a 1. Actually, I'm going to use a thinner pen here, okay? So we can get a 1. And then if we flip the coin, we can get heads, okay? So it's up to you on how you're going to proceed here. So this is my suggestion, and it's only a suggestion, okay? So stick with the number cube. We can get a 2, and we can get heads. If we roll the number cube, we can get a 3, and we can get heads. You see how I'm going in an organized way? Then we can roll a 4 and heads, 5 and heads, 6 and heads. Okay, so that's not all of the possible outcomes, right? That took care of the number cube and the one side of the coin. So now let's talk about the other side of the coin, tails. So we can get 1 tails, 2 tails. It's much easier if you go in an organized way here. Now each one of these represents one possible outcome. Remember, because you're doing two kind of separate events as one. So a 4 alone is not an outcome. The 4 rolled with a tail, that is an outcome. So how many outcomes do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So always kind of, oh, wait a second here. Okay, 9, 10, 11, 12. My bad. All right, so let's just write ourselves a note here. 12 total outcomes. Okay, and why is this important? Why is this number important? Because that's going to be the denominator in all of our probability questions. All right, let's go on to question 2. Is there any combination that is more likely to occur? In other words, look at all of these outcomes. Do any of these outcomes occur more than once? It doesn't look like it, okay? So if they're all equally likely, then the answer is no. There is no combination that is more likely to occur. You have the exact same chance of getting a 1 heads as you are a 3 tails. Number 3, calculate the probability of getting a 4 and a heads. Okay, so probability of 4H. Okay, so we know that the total number of outcomes is 12. Remember, that's this number right up here. Okay, all right, so let's look for this combination, this outcome of 4 and heads. So here is 4 and heads. Does it occur any other time? Well, we already said no, because all of the outcomes occur only one time. So we have only one favorable outcome. It only happens one time. Okay? So 1 over 12 cannot be reduced. It is in its lowest form. So please, with your calculator, calculate the decimal and the percentage. So we got a messy decimal, so I got 0.083. Again, only go to the third decimal place, and that equals 8.3%. Okay? All right, number 4. Calculate the probability of getting an even number and tails. Okay, so probability, even tails. So when we're writing out whatever probability we're calculating, you can just use the shortest form possible, even dash tails. Okay, so we know that the denominator is 12 because there are 12 possible outcomes. So let's look at this, even number. So what are the even numbers? Well, that's 2, 4, 6, 8, but we don't need 8 because it's only a 6-sided number cube. So let's look at all of our outcomes. Well, we only have to look at the tails outcomes over here, and let's mark up the ones that are even and tails. Well, there's this one, 2 tails. 2 is an even number. 3 tails is not an even number. 1 tail is not an even number. 4 tails is an even number. 5 is not. 6 tails is. So how many do we have? We have 3 possible outcomes. So we have a numerator of 3. All right. So 3 over 12 is not in its lowest form. Were you able to reduce it to its lowest form? Well, 3 is divisible by 3, and 12 is divisible by 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. Now 1/4, that fraction should be one of those numbers that you automatically have memorized. So 1/4 is 0.25 or 25%. Okay, so the probability of getting an even number and tails is 25%. That's much higher than the probability of getting a 4 and a heads if we were to compare these two probabilities. Okay, this is much more likely than this. Okay, so let's go on to example 2, something totally different. Example 2. At a restaurant, you can choose one item from each group. We have group 1 and group 2 to create a meal. So let's look at what's in group 1. Okay? Hamburger, chicken fingers, slice of pizza. All good choices. Group 2, French fries, salad, potato chips. All very tasty choices. So we're going to take one from group 1 and one from group 2 to create a meal. So list all of the combinations of meals that you can create. In other words, what are the possible outcomes? So again, let's do this in a very organized way. So I'm going to start with hamburger in group 1. Okay. So hamburger, and what can we have with hamburger? We can have French fries. Okay. Then let's stick with hamburger so that we're going in a very organized way. And we can have hamburger with salad. And then the last combination involving a hamburger is hamburger and potato chips. Okay? All right, so now we've talked about all the examples that would have hamburger in it. So now let's go to the outcomes that would have chicken fingers. Okay? So, chicken and French fries. Chicken and salad. Try to keep the codes the same here. And then chicken and potato chips. Okay. So now we've listed all of the outcomes that involve chicken fingers. So let's go to pizza. So we have pizza, and that can be combined with French fries. Odd combination, but still tasty. Then we have pizza with salad. And then we have pizza with potato chips. So are there any other possible outcomes? No. So let's count them. Now remember, hamburger and French fries is one outcome. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's write that over here. Sorry about that. 9 total outcomes. Now again, that's very important because 9 is going to be the denominator of all of our probability calculations. Okay, let's go to these math problems here. Number 2, calculate the probability of having a meal of hamburger and fries. Okay, so that's pretty easy here. Probability of hamburger and French fries. Well, why don't I give you a minute to calculate that? All right, so the probability of hamburger and French fries, well, it only happens one time. That's right here. Okay, so there's only one possible outcome or favorable outcome for a hamburger and French fries. So I got a starting fraction of 1 over 9, and because the numerator was 1, that is in its lowest form, equals 0.111 or 11.1%. So were you able to get that? Okay. So, number 3, calculate the probability of having a meal that included salad. Okay. So, probability of a meal with salad. Okay, so we know that the denominator is 12. And then I'm going to use a different color here. Let's identify all of the possible meals that could have salad. Well, that's these 3 meals. Hamburger and salad, chicken and salad, and pizza and salad. So the numerator, favorable number of favorable outcomes, is 3. 3 over 12, not in its lowest form, right? Ah, sorry, the numerator, the denominator. I was thinking about the last question. Sorry about that. Is 9. Okay, 9 total outcomes here. 3 over 9 is not in its lowest form. 3 over 9 is 1 over 3 equals 0.333. This is one of those repeating decimals. Equals 33.3%. 1/3 is probably another one of those fractions that you should just memorize what the decimal and what the percentage is, because that one's pretty common. Okay? Sorry about my mistake for the denominator. We have 3 over 9. Okay, number 4. Calculate the probability of having a meal of chicken fingers and salad. So we have this outcome, or pizza and chips. Okay, so this is going to be pretty hard to, let's just do a code here. So chicken fingers and salad, or pizza and chips. Okay, doesn't make a lot of sense, but at least I've kind of identified what the probability means. Okay, so before I even think about the favorable outcomes, let me write the proper denominator of total number of outcomes equals 9. Okay, so I'm going to use the highlighter this time. So chicken fingers and salad. So let's identify that. Chicken fingers and salad right here. Or pizza and chips. Okay? So how many possible outcomes do we have? Well, we have 2 favorable outcomes. So the denominator is going to be 2. Okay? We can choose this one or this one. So there are 2 possible favorable outcomes. 2 favorable outcomes. 2 over 9 cannot be reduced. It is in its lowest form. With your calculator, get 0.222, probably a repeating decimal, right? 2 divided by 9, yep, equals 22.2%. Okay, so on this page, in this video, we kind of looked at some a little bit more complex probability questions, and you'll need this knowledge for the homework sheets. Okay, so thanks for watching. Bye.